Hi everyone. So in the next set of videos, we'll discuss a very interesting technique that's very commonly used for deep learning training, which is early stopping. So in this video, we'll just introduce it, right? So what does early stopping means? It means that you hide part of the training set and you call it a validation set, okay? And as you train, you measure the performance of your model on the validation set. Okay, and then every time this validation error starts to go down, then you store a copy of the model parameters. Okay, so every time you get a better validation error, you copy the model parameters. You store a copy of the model parameters, and then you, at the end of training, whenever you decide to stop, and we'll discuss when to stop shortly. Whenever you decide to stop, you go to the last version of stored parameters, which basically corresponds to the best error that you obtained. So if the error goes up, if the validation error goes up, you don't store a new copy. You store a new copy only when you get an error that's less than the best error you got so far during training. Okay, so you store part of the data set as validation set, you monitor the performance on the validation set, and you consistently update a copy, you store a copy of all the model parameters with the least validation error obtained so far. Okay, now when does it terminate? It terminates when there is no improvement to this validation error for a pre-specified number of iterations that's typically used the patience. Okay, so if the patience value is 5, then if you don't get a better validation error than the best you got so far for 5 training iterations, then you stop training. Okay, that's basically the early stopping algorithm. Okay, now let's discuss a little bit. So this is basically how it works. Let's discuss a little bit the advantages, or how to perceive that algorithm from a principled perspective, right? So we can think of early stopping as a way to efficiently do hyperparameter selection with only one training, only once without retraining. What do we mean by hyperparameter selection? Hyperparameters are parameters that contribute to how the training algorithm works. So for example, the learning rate is a hyperparameter. Now let's say I want to come up with a learning rate selection algorithm, which is a form of a hyperparameter selection algorithm. Then I would train multiple times with different choices of learning rates, and I'll choose the best one, right? Now here the hyperparameter that early stopping is varying is the number of training steps, right? So I want to know the optimal number of training steps. And the advantage is that because of the way early stopping works, I could do that without retraining, right? So instead of training once with 10 iterations, another time with 15 iterations, and so on, no, it's an ongoing process of dynamically choosing the optimal number of training steps, right? Now, there is a slight problem with implementing early stopping, is that this periodic evaluation, so every time I update the parameters, I want to evaluate on the validation set. This can make my training slower, right? And ideally, this is done on parallel computational resources. So if there are parallel computational resources, for example, I'm using GPUs for training, maybe I can have a dedicated GPU for the validation evaluation, right? Or even within the same GPU, because they allow for parallel processing, maybe I have a separate thread that is in parallel doing the validation evaluation while I'm computing the next parameter update for training, right? So while I'm computing the next parameter update, maybe I'm evaluating the last one on the validation set. So if there are no computational resources, parallel computational resources available for validation set evaluation, then it's typically the case that we pick a small validation set. And this is a very important trade-off to understand. A large validation set with not enough computational resources to do the validation evaluation in parallel could be problematic, because it will slow the training down. It will make me wait until I do the validation evaluation for computing the next parameter update, right? So in these cases, usually we have a small validation set. The problem, of course, is that the smaller the validation set, the more erroneous or inexact would be the estimate of the optimal training time, because we are relying on evaluation on a small set, right? So so early stopping is actually can also one of the advantages from a principled understanding point of view, or fundamental point of view, is that it's actually an unobtrusive form of regularization, right? So unlike L2 regularization or norm penalty or explicit constraints or even dataset augmentation, all these methods are obtrusive forms of regularization. They change either the dataset or the cost function. Early stopping doesn't change any of these, right? So so that actually can be advantageous from multiple points of view. From a computational perspective, you don't change anything. It could be an advantage, and it could also so usually with obtrusive methods, they could introduce their own problems. They could come with their own problems. Like, for example, if I use weight decay, the model can be trapped in bad local minima, where the weights have small values but the cost is high, right? So every time you introduce an obtrusive form of regularization, they come with their own risks of trapping the model in a bad local minimum that corresponds to the nature of this regularization strategy, right? So another advantage is that it can be used, because it doesn't change anything about the training algorithm, it can be used with other regularization strategies as well. And that can improve chances for better generalization. Now, there is a fundamental problem with early stopping, and that's what that problem, we'll dedicate the next video to it, is that you intentionally lose part of your training set, and you don't use it for training. So that could be a waste. So for example, if I use 80% of the training set for training and 20% for validation, I effectively reduced the size of my training set by 80%, right? So I lost this data, I lost the potential of using this data to improve training, right? And that of course could be problematic. So in the next video, we'll discuss how to reuse the validation set for training. Thank you.